Continuing from where we left off with the probability theories and properties, we got to know that once it comes to probabilities, they are more or less like numerical values explaining the chances of events occurring. But other than these abstract numbers, we need to find a way to interpret these values so that they could have some kind of connection to reality. Now, in the field of mathematics, this interpretation, there are so many, or should I say, considerable disagreement once it comes to these interpretations. Okay, and for the purpose of this course, we are just going to look at three of them. Now, the first one happens to be the relative frequency interpretation, where in this case, probabilities are being assigned based on experimentation or historical data. Remember when we were dealing with the bar charts and the pie charts, we dealt with what relative frequencies, the number of time a certain what event. So we are going to use that same principle for this frequency relative frequency interpretation. We are also going to look at the objective interpretation, where in this case we are going to assign probabilities on the assumption of equally likely what outcomes. We are going to look at it. And also, finally, we shall be looking at the subjective interpretation, which others will refer to degree of belief. These are probabilities that we assign based on our ideas or what we think or our belief or knowledge that we have on the subject. So we shall be looking at this. So let's take a look at the first one, that is the relative frequency interpretation. Now, this type of interpretation happens to be the most frequently used and most easily understood, which is based on what the notion of what relative frequencies. Now, consider examples such as tossing of a tag toss, that is the tag tossing, that is the tongue tag. We could also look at tossing of a die, which were previously discussed in other previous sessions. Now you can see that all these are experiments that could be repeated, because if you should take a die, you could repeat it any number of times. Okay, these are experiments that are repeatable. Now suppose that with these two experiments under consideration, we perform this experiment n times on some sort of replication, that the event A will, the outcome will be a set of A, okay, and the others A will not work. Now let's denote the number of times or the number of elements in A, denoting the number of what replication on which A does what. Then the ratio of n of what A all over what n, which refers to what the same as the sample what sizes or the sample that we have in there. This is called the relative what frequency of the occurrence of the events in the sequence of what n replications. So all that this is trying to say is that anytime you should have a list of outcomes in a certain sample space or a certain event, the number of times that event all over the total sample space, that should give us what the probability that we are looking for, and that is being referred to as the relative frequency. So with this, let's take a look at an example so that you get to see how this stuff works. Now suppose that Lucas 2 rental would like to assign probability to the number of car polishers, and this is a pictorial or a picture of this car polisher. Now suppose that this car or 2 rental would like to assign probability to the number of car polishers it rents each day. Now the office record shows the following frequencies of daily rentals of cars within the last 40 days. So with this, let's look at something here. So let's look at the number of days. Remember, we are looking at what the last 40 days. So within this last 40 days, there were 4 days in which no one rented a car polisher. So that is why we have 0 here. Now within these 40 days, 6 days they rented only one car polisher or one car polisher. Now within that same 40 days, 18 of the days they rented what 2 car polishers, and 10 they rented what 3, and for 2 days they rented what only 4 car polishers. Now let's see how we get to estimate the probabilities for each of what these number of what polishers being what rented. Now you remember from the probability that anytime we like to estimate the relative frequency, all that we do is to pick the number of days, then divide by what? The total number of what? Days. So remember, for the first 4 days, they rented what? 0. So if we are to find the probability, then this will be what? 4 divided by what? 40. That is 4 on 40. And that is just going to give us the probability that what? 0 car polishes will be rented in any specific what? Day. Now, in that same case, we can also estimate the probability that only one car polisher will be rented, and that will be equal to what? 6 divided by 40, and that gives us 0.15. Now, we could do same after we get to the last one, and we are going to get this. Remember that the total sum of the sample space should always give you what? 1. So with this, we can estimate the probability that any number of car polishers will be rented within any what given what day. So that is how we get to estimate the probabilities or interpret probabilities using the relative frequency interpretation. Now let's look at another one where in this case we are dealing with one package distribution. Now when it comes to package distribution, a very popular online marketing system that we know will be Jumia. Suppose that let the event A be, or let A be the event that a package sent from Jumia warehouse to Western region of Ghana for second day delivery actually arrives in what? 1 day. So we are trying to say that let A be an event such that a package which normally would take 2 days actually takes 1 day or within 1 day to arrive in this west or in Western region. So suppose that with all these packages, they sent what? 10 packages, and the first 10 replications are being shown in the table that we have here. So with this, we could say that we should let an event A being that an event where packages arrives within 1 day, and a certain event A complements, which is the same as a package did not arrive within a day. Now remember that the whole point of this exercise is to determine the probability that an event that or an event will normally or actually arrives in a day. So if it should not arrive within that day, you can specify it as a yes or no. So let's come back to this table. Now with this table, we have the package number 1 to 10. Remember, we are sending only what? 10 packages. Now with the first package, did the package arrive within 1 day? So the first package, the package did not arrive within the 1 day, so that is why we have no here. Now for the second package, did it arrive in 1 day, which is yes. So yes and no knows until it gets to what? The 10. So with this, let's get to see how we get to what? Estimate the probabilities. Now the relative frequency of A. Remember, we are dealing with only packages that arrives within 1 day. So in this case, we have the first instance where we have no. So if we are to calculate for the probability, this will be equal to 1 on, if we are looking at this replication alone, this will be equal to 1 on 1, which is the same as what? 1. But remember that we are looking for what? Relative frequency of A, where the package arrives in what? 1 day. So if we are getting, for the first instance, we are getting the probability of no being equal to 1, it means that the probability of Y, that is the yes for package 1, the probability of yes for the first what package will be equal to what? 1 minus n. Now remember that we do have n to be equal to 1, so it means that the probability of a yes, that is a package arriving, the first package arriving in 1 day, will be equal to what? 0, because 1 minus 1 gives us what? 0, and that is why we have 0 what in here. Now remember that we are looking for relative frequency of A, and A is when an event where the package arrives within 1 day. So we are looking for situations where we are going to get what? Y, that is yes, 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 what? So anytime we get a no, it means that we have to subtract it from 1 so that we can get the probability of what? Yes. So for the second what instance, for the second package, in this case, we are having what? A yes. And with this yes, we have what? Two packages at this instance. That is package 1 and package 2. So if we like to calculate for the probability of the second package, which is equal to y, this will be equal to what? 1. That is the first package that has arrived within 1 day. And remember, this happens to be what? The second package. So for the second instance, we have no of 1 and y of what? Also 1. So that is why we have 1 here. So once we do this, remember this is just going to give us 0.5, and that is exactly what we have here. Now let's look at the third one. In the case, or before we get to the third package, we've received what? 3 packages were so far, and the third package also arrived in 1 day or within 1 day. So in this case, we have what? 2 packages arriving within 1 day. 2 out of 3 packages arriving in what? 1 day. So the probability of the third instance, that will be the y, will also be equal to what? 2 out of what? 3. And this is just going to give us what? 0.6667. Now the fourth package 2 is going to be what? 3 on what? 4. And that is going to give us what? 0.175. Now let's look at the fifth one. You can see that the fifth one happens to be what? No. Now for this fifth one, you can also estimate it in this way. Now out of the 5 packages, we have what? 3 packages arriving within 1 day. So it means that we have 3 yeses. So probability of package 5, this will be equal to what? We have 3 years, so it will be equal to what? 3 divided by what? 5, and that is just going to give us this probability. Now in this same case too, we have what? Still 3 packages arriving in 1 day, so this will be still 3 on what? 6, and that is giving us what? 0.5. Now for the seventh package, we have what? 4 packages this time, because we have 1, 1, 1, 1, 1. 4 packages arriving within 1 day, so this will be equal to 4 divided by what? 7, and that gives us this amount. So the same can be done for what? The subsequent events that we have here. So that is how the relative frequency interpretation is being done. Now suppose that we should have so many what? Packages, more than 10 this time. Let's see how this is going to look at in future. Let's try to plot this. Now suppose that we are to look at more than 50 packages. This will be the various probabilities until it gets to this point. So you can see from this point that when we had 5 on 10, we are having somewhere, where we have 5 on 10, that is, if we should have 5 packages out of 10, we are going to get 0.5. okay, that is in this case. And in case where we should get to the 15 package, and 9 of them were able to arrive within 1 day, so it will be what? 9 on 15, and that is what we are having as 0.16. Now if this should continue, you can see that at the end of the day, these fluctuations that we see will be what? Dampening down, meaning that as we move on, this will be getting close to what? A very straight one, or let's say a fixed point, a fixed probability. Now let's try to look at it from a very longer term in here, or we should normally call it the long run. Now you can see that from the beginning it's just going to fluctuate, but as we move on forward, you can see that this is approaching a certain what? Probability, somewhere more or less like what? 0.6. Now this 0.6 that you see here is referred to the long run. If we should look at it from some sort of long distance or future ahead of us, that is the basic, or let's say the standard probability that we shall come to arrive at. Now remember that this is called the long run, or others would like to call it the limiting what? Frequency. And this limiting frequency is some sort of very difficult to obtain, and looking at having to perform this interpretation of probabilities one until we get to, remember, this is about thousand. This is so much, and that is what the frequency, relative frequency interpretation one does. It calculates the probability at every given point in time until it gets to what, that long run, which is some kind of what, long. Now there is the second type of interpretation which tries to what, estimate this long run what, probability, that is the limiting what, frequency. So this objective frequency or objective type of what, interpretation tries to what, identify this limiting frequency that we observe during the relative frequency. So suppose that the probabilities are assigned to event in accordance with their limiting relative frequencies. Then the statement such as the probability of a package being delivered within 1 day of mailing is what, 0.6. Now remember that with this example, we came out that as we look at it from the long run perspective, the probability tend to what, converge towards 0.6. So in the long run, we could say that, or we could say that the probability of a package arriving within the region within 1 day is equal to what, 0.6. And that is to say that roughly about 60% of packages being sent could arrive within the region within 1 day. So this is what, like, generally the limiting frequency or limiting probability try to what, to do. That is the interpretation. So let's look at more things. Now similarly, we can think of an event B that an appliance of a particular type will need servicing while under what, warranty. Now we've been buying so many appliances, electronic gadgets from the store, and if you are able to visit a reputable store, you are likely to get a warranty. Now suppose that this probability of obtaining or an appliance needing a service while under warranty is equal to what, 0.1. Okay. Now if suppose that we estimated this probability to be 0.1 in the long run, this could be interpreted as 10% of such appliances will need what, warranty what, repairs. So that is how this objective interpretation tries to what, do. But one thing that you should note is that this does not mean that 1 out of what, 10 will need service because of this 10%, or that exactly 10 out of 100 will need service, because 10 and 100 cannot be considered to be a long run. Once we are talking about long run, it should be something far away. And once it comes to this, identifying what a long run is really an issue once it comes to this objective interpretation. So this is something about this objective interpretation, and let's try to look at it more of it. Now, fortunately, there are so many experiments that we could also think of in which their limiting probabilities could just be what, estimated. And these probabilities, we know the outcomes already because they are easily to what, to repeat and all that. So if an experiment has n possible outcomes, this method will probably assign 1 on n to each outcome. For instance, if you have to have a toss of a coin, you could have this, and this is the same as for every coin, either we are going to have a head or a tail. So the probability of a head, because we are having two outcomes, each of them is just going to get 1 or 2. This giving us what, 0.5. Now thinking about rolling of what, a fair die, which we are going to have what, 6 outcomes. Their probabilities could be estimated as what, 1 on n, which in this case our n is equal to what, 6. So for each of these outcomes we'll have their limiting probability to be 1 or 6. Now because this objective form of interpretation is being based on the notion of limiting frequencies, its applicability is limited to experimental situations that are repeatable. So in situations where we do have experiments which are not repeatable, this comes to be somehow very difficult to estimate this limiting what, frequencies. And that brings us to our next form of interpretation, which is a little bit what, flexible. And this interpretation is referred to as the subjective form of interpretation. Now, this interpretation is often used in connection to situations that are inherently what? Unrepeatable. Because, as I said from the beginning, we are going to generalize the meaning for an experiment in this course. So, we could have experiments that are repeatable in the form of tossing of a coin, tossing of a die, rolling of a die, and all that. All these experiments are what? Repeatable. But in cases where we have experiments that are not repeatable, then it means that we have to dwell on some sort of what interpretation, and the subjective form of interpretation will be an appropriate in that instance. Now, in situations or in statements like the chances are good for a peace agreement, it is likely that our company will be awarded this contract, and because that their quarterback is injured, I expect them to score no more than what 2 goals against us during the Vice Chancellor's Cup tournament. Now, those of us who happen to follow a team that is a football team, we all have our beliefs and all our thinking based on our team, our performance of our team. Now, suppose that a Real Madrid and a Barca fan are standing right here, and there's going to be an El Clasico, that is a match between these two great teams. What a Real Madrid fan will say is likely that a Barca fan is also going to say the same. For instance, the Real Madrid fan is going to say that with this match, my team is going to win. Now, the Barca fan is not going to agree on that. The Barca fan will also say, no, there's no way Real Madrid is going to score my team. Definitely, Barca will score Real Madrid. Now, because there's some sort of subjective thinking and ideas here, this sort of interpretation is best suited with this subjective interpretation, where everyone has his or her own opinion, and that is what this interpretation is about. So once it comes to statement, just like it is likely that our company will be awarded this contract, another company will also be saying the same thing, thinking that he too might be having chances of getting that contract. So once we have situation like that, this subjective form of interpretation is quite adequate for that sort of situation. Now, with this subjective interpretation, we can use any data available as well as our experience and intuition, but ultimately the probability value should express our degree of belief, what we believe the outcome is going to be. So at times we might have access to data on which we are going to base on to make our decision and interpretation, but in actual sense, our decision is much more influenced by our intuition and our notion and our belief about whatever will be happening. And this sort of subjective interpretation is a precise way of interpreting probabilities, such that people or others would like to refer to this as the best probability estimate, often and are obtained by combining estimates both from the objective and the relative frequency approach with the subjective estimate. So with this subjective, you can combine data and as well as your intuitive notion about the experiment being conducted. So with this, combining several interpretation methods is likely to yield something better. So that is what this subjective experiment is about. Now let's try to look at an example of this subjective reasoning or interpretation. Now for those of you who have been visited gambling institutions such as the super bets, normally you go there and you meet so many games being displayed on there. It could be soccer, it could be anything. So suppose that for a specific game you consider 40 pesos to be a fair price for a gamble which pays you 1 Ghana cedi if Real Madrid should win a particular game tomorrow. Then 0.4 is your subjective probability for that event. So with this 40 pesos, you are going to bet on this 40 pesos in order to get that one Ghana cedi. And one popular term that they would like to use is odds. So you'll be hearing words like Real Madrid, the odd for Real Madrid is like 0.4 and that, okay? So these are all subjective word probabilities. But with these probabilities, they are subjective because whatever you say, someone might also what thinking or might think something what different from whatever you say. So that is also one thing. Now let's look at another example with an analyst. Now with this analyst, there is a company whose analyst has made the following probability assignment. So we can have analysts coming up with this, okay, with a certain experiment such that the outcome, if the outcome is within 10 and 8, then it means that there will be a net gain of what? $18,000, okay. Now if that happens, it means that he's assigning a probability of 0.2. Now in that same case, if the experimental outcome should be within 10 and -2, they are likely to make what? 10, a gain of what? $8,000. Now if you should be within negative, in that case they are going to make a whole loss. And all these are being assigned with what? Probabilities. Remember how we estimated our probabilities? So that is how the probabilities are being interpreted. So for this section, we've looked at the various form of what interpretation. That is the relative frequency interpretation, where we get to what interpret based on the frequencies of the data set at our disposal. We took a look at the objective interpretation, where we get to experiment on this based on repeatable experiments. Now, in cases where we don't have or we do experiments that are not repeatable, we can think of the subjective, which is based on our degree of belief, what we think, which is based more on our intuitive understanding. And that will be the end of this session. So for the next session, we shall be looking at more probability rules. And this brings us to the end of this session. So I'll see you guys at the next session.